right, how can I resist making a video for this one? We've got a pretty tough question here, so I think it's probably worth me running through it with you. You'll see that it's just all of our rules applied the way we always have been, but I understand it's pretty tricky the first time. So we're looking at part B of this question. We've got to find the second derivative of q in terms of v. So d squared q dv squared. So let's find dq dv and then do a second derivative in terms of v. So let's go ahead and do the first bit. So I'm going to try and find d dv of each term. So this is 3v squared plus d dv of 2q, and that's going to equal the d dv of this product, which is 2vq. So okay, the first bit's easy enough. We've got an expression in terms of v, so the derivative of 3v squared is just going to be 6v, and I reckon we're all okay with that. Let's move on to the next bit, d dv of 2q. So remember, this is where we're going to use our chain rule, and I'm going to go d dq of 2q multiplied by dq dv, which is what we're trying to find. So that's good that the term has turned up, and you can probably do this in your head. If you've done the rest of the exercise, you can probably go straight to 2 times dq dv, but I'm just going to write the working out because it's not going to hurt us. On the right here, we have a product rule. We've got one term, 2v, being multiplied by the other factor of q. So I'm going to do the derivative in terms of v of the first half, and it might make it easier if you sort of indicate that you've got 2 bits there, although now the v doesn't look like a v anymore, but you get the idea. So the d dv of 2v is just 2, and I leave the second half alone. So remember, the derivative of the first half times the second half, plus I leave the first half alone, and I've got to do d dv of q, which is of course dq dv. d dv of q, the q just ends up on the top and you get dq dv. Excellent, I've got my dq dv's. Let's keep them together and get everything else on the other side. So I'm going to leave the 6v here, this 2q, I'm going to subtract 2q from each side, and on this other side I'm going to have my dq dv's. Already over here is 2v times that, so I'm going to keep the 2v. And the other term that I'm subtracting, remember, d dq of 2q is just 2, so I've really got 2, all of this. Let me get another colour out and make it a bit clearer what I'm saying here. So this bit that I'm going to circle in the red there, all of that, d dq of 2q, well that's just 2, isn't it? So what I've really got this term is 2 times dq dv. Easy enough, therefore, when I subtract it, to just say this is 2v minus 2. And I've factorised it there, so the dq dv is out the front. dq dv on its own, easy enough to see now. I'm going to have this 6v minus 2q. Let's factorise that because I'm sure you've already seen there's a factor of 2 on each side. And to get this on its own, I was dividing by 2v minus 2. I'm going to factorise that as well. So it's 2 outside of v take 1. 2's cancel. And you've got your first derivative dq dv. And that's what we wanted. Okay, how do we go about doing the second derivative? Let's make ourselves a little bit more room here. And let's go through and see what we're doing. So the second derivative, I need to go d dv again of this expression. And here I've got dq dv equals 3v take q over v take 1. So on the left-hand side, the derivative in terms of v of dq dv, we write that as d squared q over dv squared. That's the second derivative, that's what we're wanting to find. On this right hand side, I don't have a product this time, I have a quotient. So I'm going to use my quotient rule. So I've got to do d dv of the top bit. So remember your quotient rule, I'm going to have u dash v minus u v dash over v squared. So you're thinking about that in your head. You got that in your head. Okay, I'm going to remember that. So let's go. The ddv of 3v take q. So the top bit, well, the derivative of that is going to be ddv of 3v is 3 minus, and I'm going to have dv dq turn up again, aren't I? Oh, sorry, dq dv. I'm saying it backwards there. So ddv of q is just going to be dq dv. So that's my u dash. That's got to be multiplied by v, and my v term is actually v minus 1. It's a bit annoying that we happen to have v in our rule and in our expression. Maybe I should have done a dash b minus ab dash, but I'm sure you're coping. Minus. Then I leave the first one alone, so that's just 3v take q. Leave the first bit alone. Multiply by the derivative in terms of v minus 1. Well, the derivative of v is going to be 1, and the derivative of negative 1 is going to be 0, so that's actually just going to be 1, which is nicer than a lot of the other things we've been dealing with. And on the bottom, v squared, so the denominator just becomes that bottom term, v minus 1, squared. We are making progress. Let's see if we can keep going. I might need to... Does this thing slide around? Oh, look, it does. I'm sure that's not helping you at all, and it's probably less distracting with my face there anyway. But some people say they get something out of it, so you're stuck with it. Here we go. Let's simplify this. D squared q over dv squared. What was dq dv? Oh, we already had an expression for that, didn't we? It's 3v minus q over v take 1. So I'm going to substitute that in. So it's 3 minus 3v take q over v take 1. Look, that's being multiplied by v take 1. That's going to help us. And this other bit is just going to be negative 3v, and I'm going to distribute that minus sign. Negative times negative q becomes plus q. This is all over v take 1 squared. Okay, we're nearly there. I've just got to expand this bracket, don't I? So keeping our left-hand side going, d squared q over dv squared. What's going on here? I'm going to have 3 multiplied by that v take 1, so that's 3v minus 3. And I've got my minus sign, so I'm going to put the minus sign down. And now you'll see, when I take this second term, the v minus 1 there is going to cancel with that v minus 1. So I'm just left with negative 3v take q. I'm keeping that bracket around it because we're going to need to distribute that minus sign, and I have a feeling if I try to do it all at once it might not work. Some of us might get lost, so let's just see what I've done there. The 3 multiplied the v, the 3 over here multiplied the v take 1, that was okay. Then the second term, the v minus 1's cancelled. I've just got negative. Because there's a vinculum underneath that bit, that numerator, it's all grouped together, so I keep brackets around it. I've got the rest of this, minus 3v plus q. And this is all over v take 1 squared. Up to our final little bit of the simplification. D squared q over dv squared. 3v minus 3v. Well, that's nothing. And then I've got minus 3v. So I'm going to have negative 3v. Okay. I'm going to have a negative 3. That's the only number that's going to be on. And then this negative q is going to give me positive q. I've got another positive q over there. So altogether I've got 2 q's, negative 3v, and this negative 3. That's my numerator. And the denominator, v minus 1 squared. And there we have the second derivative. Implicit differentiation, second derivatives. Second, third year university students might struggle to do that. Some of them, most of them. You guys are good enough to do it. It's a little bit complicated. A quotient rule with implicit is nasty, but you can see we get to the right answer. If you look up in the book, I think it says 1 minus v squared, but you should all know that 1 minus v all squared and v minus 1 all squared is going to give you the same answer. So there you go. All right, catch you tomorrow. Hope that helps. Bye.